So this is where I left off when I ran out of time. So -2, 0 is our first point of inflection, and then our other point of inflection is going to be halfway between -2, 0 and the minimum down here of 1, -5. So if we do the midpoint, -2 plus 1 over 2, comma, 0 plus -5 over 2 will give us the other point of inflection of, looks like -1/2, comma, -5/2. And that's pretty close to where I had my dot earlier. So these 2 points of inflection here, we only had 1 point of inflection on this one, and we had 3 points of inflection here. So as I move forward, we also have intervals of concavity that we want you to practice, and it basically boils down to if you're concave up or concave down, and it's the U shape. So as we look in this example, you see how it's a downwards U. So we would say that's concave down. Some people put an arrow pointing down, that's totally fine as well. Concave down, CC down, it would be from -infinity until we get to that midpoint that we found on the previous problem, the x value being 2, and then it's concave up from 2 to infinity. And this time the general consensus is to use parentheses, not brackets, which may seem weird that before I was going with brackets, but now I'm going with parentheses. But as we look at this next one, let me do concave down again first. So it's an upwards U to the left of that first point of inflection, but then it's a downwards U. So that's from -2. I think I called that -1/2. If I go back a slide, I'm pretty sure that's what I called it. Yeah, the x value is -1/2. These are the same graphs, by the way. I don't know if you noticed that. These two graphs are the same that we're looking at here. So then where is it concave up? It would be everywhere else, all the other x values. So we're looking at from -infinity until we get to -2, union from -1/2 to infinity. So as far as our definition goes, I would just break it down to, we're looking for the x values where the graph opens up. How about this? Has an upwards U. Up. That's a terrible up. Upwards U shape. That's for concave up. Concave up. And a downwards U shape. Downwards. I'm really struggling right now. U shape. That is concave down. And hopefully that definition matches what I talked about over here. So now we're going to put it all together. Everything from ages ago. So as we look at this is our example we're going to look at. I'm just going to kind of go through it. And feel free to do this on your own and see if you get the same answers. So domain and range goes infinitely left to right, infinitely down to up. My zeros, it looks like x equals -2, 1, and 3. I would argue that they all have a multiplicity of 1 for all of them. Typically, if it has a multiplicity of 1, we don't even have to write it down, but I know the directions say state their multiplicity, so that's why I'm doing that. Intervals for x, where it's above the x-axis, so it's not on. So we're going from -2 to 1 is above the x-axis, from 3 to infinity. If I'm going too fast, please, please, please pause the video. Below the x-axis, 1 to 3. So as I'm looking at this, my left-end behavior, we did this as x goes to -infinity. Let's see, they didn't really name it, but up here they called it f. So let's go ahead and stay consistent. F of x is going infinitely down. My right-end behavior as x goes to +infinity. function is going infinitely up. Now, I would call this a cubic, and because as you look at your all of your zeros having a multiplicity of 1, I'm looking at the multiplicities and I'm adding them together. Equals 3. So maybe a better explanation, if I ask for one on a test, is to say the sum of the multiplicities. Where's the function increasing? I'm just going to switch colors because I'm tired of that one. That's up and to the right. So up and to the right from negative infinity to negative 1. But it's also increase. Oh, there I go again. I switch back to a parenthesis. Again, increasing, decreasing, I don't care if you do a parenthesis or a bracket. You will find teachers that do different things. Then 2 to infinity, up and to the right. Whereas the function decreasing, that would be, there I go again, doing it again, from negative 1 to 2. I'm going to stick with my brackets, though. My most recent professor stuck with brackets for this. Relative maximum. All right, well, we finally got to something that is new. So that is relative to the points on either side. I might as well mention it now because some teachers do get picky about this. Is when they ask for a max value, they're looking for the y value. For our purposes, you can just give me the point. Okay, that's good enough for me. But another teacher might say, no. I need you to tell me the max value is the y value, and then say at x equals negative 1. So the reason why they do that is it's sort of like if you have money in your pocket. I don't really care which pocket you have money in, but maybe I care about how much total money you have. Like, I guess I shouldn't say total money. I just am saying, like, okay, do you have a $5 in one of your pocket? Well, you're not going to tell me which pocket it's in. That's what this x is telling me, is this is the x location where you get the max value of 5. It was probably a terrible analogy, but I'm sticking with it. So as I look at the relative min, that's the lowest point on the graph. Well, I should rephrase what I'm saying. Lowest relative to the points on either side. But again, another teacher might say, no, you have to tell me the value is the y value at x equals the other value 2. All right? I'm just trying to prepare you for the future. That's why I'm bringing that to your attention. Now, the absolute is the absolute lowest. So is negative 2 the absolute lowest? No. It goes infinitely down. So there's none. What about an absolute? Oh, whoops, I did min already. Now the absolute max, is this the highest point? No, it goes higher to the right. So that one is still none. I was just looking at the wrong thing. Let's look at our point of inflection. This time the point of inflection is halfway between my max and my min. So about halfway between negative 1 and 2 is about 0.5. Or you can just write 1/2. That's what I would do. This is an approximation, by the way. It's not the exact. And then halfway between negative 2 and 5, well, if I add them together, I get 3 divided by 2. 3/2. So where is it concave up? Where is it an upwards U? That would be the x values from here to infinity. So about 1/2 to infinity. And concave down would be from negative infinity to 1/2. So again, please pause the video. Make sure you understand. Soak this in. And then I'm going to move forward with the next page. So here's another one, getting you to practice. Now the domain is still negative infinity to positive infinity. But now, remember, read the graph from the bottom to the top. There's a highest y value. That happens at 6. Now look at your zeros. So I'm going to write it in a sort of a weird way. When I don't have a multiplicity or if I have a multiplicity of 1, I'm just going to write those answers. And then I'm going to write a separate line that x equals negative 2 bounces off the graph. So that's a multiplicity of 2. So as I look at the sum of those multiplicities, sum of multiplicities. We're looking at 1 plus 1 plus 2. This is my clue that I have a quartic polynomial. I'm kind of ahead of myself there. Let's go back to pink. Where's the function above the x-axis? So we're looking at from -5 until we get to -2. We can't include -2 because it's on the x-axis there. 2. And then where's it below the x-axis? -infinity to -5. 2 to infinity. Remember, you can pause this video and try this on your own and then watch it and see how many answers you get right. Let's see, they call it f again. It's going infinitely down and to the left, same with to the right. As x goes to positive infinity, we're going infinitely down. So that would be negative infinity. Let's keep powering through this. Where is it increasing? So it's increasing right away from negative infinity to -4, starts going down, but then again from -2 to 1. So where is it decreasing? From -4 to -2. It's going down and to the right, and then from 1 to infinity. So now the relative max, relative max is here and here. So we do have two relative maxes. Except I can't really see the other one, 1, 6. But there's only one absolute max. So which one of those values has a higher y value? That would be at 1, 6. And again, if you follow my advice from the previous slide, you might say max value is 3 at x equals -4. Max value is 6 at x equals 1. Now the relative min, sort of tricky here, but I have confidence in all of you. Again, you can say it's a relative min value of 0 at x equals -2, but is that the absolute lowest point on the graph? No. There are none. So our point of inflections are halfway between those values. So about halfway between -4, 3 and -2, 0. I would say it's -3, 1.5, or 3/2. And we have another point of inflection halfway between this. So about -1/2, 3. Something else that's kind of important is, so we have a quartic polynomial. That means we have 4 zeros. Technically we have 4 zeros because of the multiplicity of 2. If you subtract 1 from the number 0, so 4 minus 1 is 3. That's how many turning points you typically have on these. And if you subtract 1 from 3, you get 2. That's typically how many points of inflection you have, inflection points. So it's a good way to check your work as you go. I want to hurry up and finish this. So concave up is an upwards U. That would be between the x values -3 and -1/2. And then concave down would be the other way, the way where we have a downwards U. -infinity to -3, and then from -1/2 to infinity. I believe you should be ready for the homework. And we are done with this.